Hi everyone. Today we're going to learn the third and final method of charging an object, and that's charging by induction. This is probably the hardest one to properly explain because there's an extra step involved. So charging by friction is when two objects rub together. Charging by contact is when an object physically touches another object. Induction occurs when we use a charged object to charge another one without actually touching it. So let's start by going back to something we did the other day, which was this balloon simulation, charging by friction. You know, if we take a balloon and rub it on this sweater, or in real life, you could take a balloon and rub it on your hair, we know, even though we can't see it physically, the balloon ends up picking up electrons either from the sweater or your hair. Now, I want you to pay particular attention to the wall as I bring the balloon towards the wall. What happens to the charges? Notice how as the balloon gets closer, the electrons in the wall are actually getting pushed away. Now that makes sense because we know that like charges repel. Electrons push away other electrons. So by pushing away, they're actually inducing a charge on the surface of the wall, and that's where the name induction comes from. The balloon isn't actually touching the wall yet, but it's having a charging effect on the wall. It's pushing the electrons away. This is why in real life that if you were to repeat this and just bring the balloon to the wall, this is why the balloon ends up sticking to the wall, because we have a negatively charged balloon and the area where the balloon is touching the wall is now positive because electrons have been pushed away. Okay? You'll notice again, just something we keep talking about, that notice how it's only the electrons that move. It's never the protons. The protons are locked in place. So this is the easy part of induction. You bring a charged object close to another object and it pushes electrons away. It effectively does what we call polarizes it. So here's a picture showing an example of polarization. You'll see that definition in the lesson. Overall, this sphere right in the middle is electrically neutral. It has an equal amount of positive charge and negative charge. When you bring a charged object close to it, look what happens. We know that the electrons are attracted to positive charges, so all the electrons move to this side of the sphere, trying to get to the glass rod, which leaves this side of the sphere negative, and then the opposite side, the opposite side of the sphere positive. So we've induced a polarized charge within the sphere. Again, that's from induction. It's important that the rod doesn't actually touch the sphere, or else charging by contact takes place. If you were to take this rod away, this would go back to being neutral. So when we say polarization, we mean that the charge within an object has been separated to opposite sides, and that's easily demonstrated through the initial aspects of induction. So let's go to the video here for a second. Once again, we're going to see one of our electroscopes that we saw yesterday. This is a metal leaf or a foil electroscope. It's just a metal rod. At the top, it goes inside a plastic chamber, and at the bottom of that rod, there's just a small piece of aluminum foil. So as always, we come back to our classic plastic rod. Right now it's neutral. We can see if I bring it close, nothing appears to be happening. Just like before, I'm now going to give the rod a negative charge by rubbing it with some animal fur. So as we rub it together, the plastic rod rips electrons off of the animal fur. So now the plastic rod is negatively charged. We should see that if I bring it close to the metal leaf electroscope, we should see movement, and there you saw it. Just by bringing it close, we see a deflection of the foil. And again, that makes perfect sense. What we are seeing is the same thing we saw in this diagram, except I had a negative rod. It causes, with my negative plastic rod, it causes the repulsion of electrons within the electroscope. And as soon as it gets close, all those electrons get propelled down to the bottom of the electroscope. So the bottom of the metal rod and the aluminum foil both have a negative charge. They repel each other. Notice how as soon as I bring the rod away, the electroscope goes back to being neutral. So here's the interesting part, or the more challenging part of induction. I want to make sure, or somehow end up with an overall charge on the electroscope without actually touching it with the rod. So here's where that extra middle step comes into place. While the electroscope is polarized, or while there's that induced charge, I'm going to come along with my other hand and I'm going to touch this little metal sphere at the top. So again, watch carefully what happens. I bring the rod close. You can see the deflection of the foil leaf. I'm just going to bring my other finger and touch it. So I want you to pay attention because the plastic rod never actually touches the electroscope. Now I'm going to take my finger away and take the rod away. The rod's now completely gone, and you can see that the metal leaf is being deflected. So now we've induced, and induced because we never actually touched it with the rod, a permanent charge within the electroscope, and that's charging by induction. So charging by induction, we bring a charged object close, but not touching another object. That induces a temporary charge. And while you polarize it, you come along and you ground it, or in this case, you touch it with your finger. That's going to cause electrons to, in this case, leave the electroscope. So again, just in terms of what we're doing here, imagine this is the plastic rod that you just saw. We bring it close to the metal leaf electroscope. Electrons are repelled by the rod. They want to get as far away as they can, so they all flee to the bottom. The leaves become negatively charged and they repel each other. You come along and you touch it, and remember those electrons in the electroscope are repelled by this rod. They don't want to be anywhere near it. Now they have a path to the ground, or they have a path into you. So the instant that you touch it, all those electrons in the electroscope actually flee into your finger, into you. So electrons are now physically leaving the electroscope. So now, when you bring your finger or move your finger and the negative rod away, there's far less electrons in the electroscope now. So it has an overall positive charge. It's now permanently charged. The leaves deflect. So again, notice that intermediary step that makes this a little bit more challenging than friction in contact. So the act of bringing a charged object close but not touching another one is called charging by induction. It induces a temporary charge. And if while you do that, you ground the object or touch the object, then you're going to cause a movement of electrons away or into the object, giving it a permanent charge. So here's the diagram from the textbook you're seeing here. This first set of pictures explains what happens when you have a negatively charged rod brought close. The second set of diagrams shows what happens if you have a positively charged rod brought close. And then you're just going to have to resketch it or sketch a new one any way you see fit in the box. And now that we're done the 3 methods of charging, you're going to attempt a short little quiz. So here in part D, you're going to see a link that's going to take you to a fairly straightforward online website called the Physics Classroom. You click on the link, it brings you here. You just need to go down to this window here that says name that charge. You'll probably want it full screen, so just click on the 2 arrows in the top left. And then it just says enter your name, and then you can start. And then it's just going to identify a couple scenarios where you're asked to predict what kind of charge 2 objects in this scenario end up with. Okay? So once you do that, you're going to complete that yourself. I don't want to show it away. There's only 7 questions. When you're done, just to show us how you fared, take a screen cap of your overall score. So you'll notice, of course, I'm a genius, progress 7 out of 7 when I did it. So just take a screen cap of your score and paste it in right here in your OneNote. So those are the 3 methods of charging: charging by friction, charging by contact, and charging by induction.